that Diggles is also a Pokemon Master?
We are recording this. This is perfect.
That's
Diggles
cool. Anyone who wants to add me in Pokemon Go, hit me up. Oh,
Hey,
yeah,
Ray,
right.
dude,
We'll do it after the call. But I'll share my trainer info. Yeah.
You know, the funny thing is, Rahito is also a big Pokemon person.
Totally.
Yeah, our advisor, the Sanrio CEO, is a huge Pokemon guy. We took him to the baseball game, and he was like finding Pokemons everywhere. Anyways, I digress. Hey, everybody. This is the Constellation team. Mathias, Benjamin, Wyatt, myself. Kind of back to do some more, breaking down, deconstructing of Constellation from just like a more organic perspective we call the coffee talk. And today we're having a little roundtable organic discussion around Ethereum versus Constellation, which takes us back to really the beginning of who Constellation is. And we thought it would be important because it's such a big part of our DNA. Ethereum is a big part of our DNA, and maybe kind of breaking down the differences of Ethereum and why we saw the need to create Constellation would help kind of start to plant a vision for people. And, Wyatt when I first met Wyatt, he talked, he was building an application called Rakugo on Ethereum to really test the limitations. And I want Wyatt to kind of dive into this perspective of a distributed computing engineer looking at DLT technology with the lens of somebody that's built many applications and infrastructure tools. So maybe Wyatt, you want to start diving into the origins of what you saw as the main differences between what you wanted to see as an engineer and what Ethereum could offer.
Yeah, totally. So, what Ethereum did and the idea of like a smart contract, and it wasn't, so Ethereum was also contemporary with, I believe, Counterparty too. And so just the notion of a smart contract in general was pretty like amazing, actually, just as a bystander. I mean, I was aware of the blockchain community at the time, sort of through, this was like pre-Mt. Gox, that whole thing, like back in college. And it really was almost like the manifestation of this kind of like vision or dream or something that I think, well, obviously like the people who created it saw as well, where using the notion of distributed consensus can actually, decentralized verification of some type of an application. And how can we actually like repurpose consensus in order to do something other than like validate a ledger? So it was really a great, still game-changing idea. It's going to be around forever, and they have their use cases that they're perfect for, which is great. And so I was just playing around with it because I thought it was fun, and I worked on a project that was going to tokenize some people's information and something kind of like Steemit, but to actually make tokens out of your content that you're creating. So and that was pretty fun. And I remember in that process, I ran into an issue where I was like, how on earth could I actually like process enough information to create a like app that would be like used by, I don't know, someone who's reading, like, let's say that someone at like Vice wanted to read this, or the New York Times, like someone who gets that much traffic on their webpage, right? Being able to actually integrate some kind of token mechanics orchestrated by a smart contract in those processes wasn't really possible. And the reason why, there's many, but it's really just this the issue that traditional blockchains are a distributed system that operates in serial. And what that means is that every single node has to do the exact same thing. And in order to actually create these services, the things, the backends, if you will, for these kind of like consumer-facing apps, people rely on this notion of concurrency or parallelism which allows us to actually get all of those computers to work together in order to just make things faster. You know, it's like trying to drive a carriage with one really big horse as opposed to like multiple, hopefully really big horses. You know, just through that process, it was really just fundamental that blockchains in general, you know, are going to have a lot of issues with, you know, being able to process information both in like magnitude and in speed that could really integrate with the kind of stuff that serves up your web pages, or, you know, runs the kind of like AI stuff you see on cars, you know, doing that Google mapping thing, or rather what those things are for. So there needed to be like something sort of, you know, we needed to repurpose this concept in order to have the same kind of architecture, you know, that we needed for these kind of consumer apps. And it really just, it got me thinking, you know, how could we actually achieve some kind of parallel consensus? And what would that do with the idea of a smart contract? Like, would it be, could you just, you know, could you use smart contracts in this kind of like parallel model? Is that really what you'd even want to do? And yeah, I mean, push came to shove, and you know, Constellation exists.
Yeah, I think it's interesting though. Like when we first talked a long time ago, it was that these very simple use cases or were able to be met on a distributed ledger, but nobody was actually building stuff. And yet there was a whole opportunity and a vision for devices to kind of manage one another, interact and connect with one another. So there was this like evolution from Bitcoin doing transactions to Ethereum having its first kind of application layer with smart contracts, and the ERC20 token, to a further evolution of having some sort of application support in some sort of meaningful context, that if you wanted to take, if you wanted to use this distributed ledger technology for any sort of meaningful consumer application or enterprise use case, it just wouldn't be able to work. So everything out there was just kind of, it wasn't really working correctly, or what the vision, the infrastructure wasn't in place for the vision that we saw. And I thought that really kind of boiled down to like, how, you know, where does Ethereum stand with what they're really good at, what certain use cases they can deliver on versus what we saw in our experience, you know? And I think that kind of goes hand in hand with, you know, we live in Silicon Valley, we talk about flying cars, connectivity, IoT, big data, machine learning, AI, like it's going out of style. And yet, and what Ethereum really kind of ushered in was a great use case around logistics, and some of their use cases pertain to logistics. But you specifically saw more connectivity happen between devices, and almost like validators become data miners. So people validating data were like data miners. Am I right?
No, 100%. I mean, you know, the idea here was in the same way that that Ethereum wanted to validate the state of some kind of you know, application or the execution of some code. I wanted to validate like actual data. Why does this necessarily have to be in, you know, perhaps a sandboxed environment with specific, like in their case, like opcodes that they verify? Why wasn't it possible, or financial transactions in that case? Like, there are so many different like issues right now with just shitty data that I've dealt with in my entire life and my career that can just, you know, crash stuff. I mean, literally, like if you just have a, you know, bad data, your models are going to be shit. Like if you have corrupt data, you're going to break clusters. It's a huge problem. And I mean, it's also kind of like on the same par with like information security. Like if you have these like real life systems that are reading information, if you talk about a self-driving car, what's to stop someone feeding it bogus information and drive you off the road? I don't know exactly what is being done. I mean, I know what we've done in some of our cases, but this is a huge problem. I mean, it's both in the information security space and also kind of in really just in like a user experience or performance space. I mean, like we need to address issues with incorrect, or rather just like, bogus info, and all of our devices all around us are generating tons of it. It's something that we're already using and indexing to make decisions on. Would it be possible to repurpose the notion of consensus in order to actually get some measure of accuracy on the state, the real world like experiences, the actual like what's happening right here, right now, that some device is currently next to as well? So like if I wanted to figure out maybe like what's the temperature in a room, why should I, how do you want to actually gauge that or make that decision? I mean, like in some cases, someone could write an interesting consensus model, which just takes all of them and does an average. I mean, that could be that. But, using these kind of more, basically like creating and repurposing the notion of consensus for just arbitrary data, it seemed like the real key to unlocking this kind of like smart city, interconnected future world, and even allowing us to just have security around our, mobile, I wouldn't say mobile generated, but like the fact that like, you turn on your TV with your cell phone, or you start your car with your cell phone. How do you actually create some measure of security or some kind of some kind of, I don't know, audit trail of these processes that could actually be like mission critical or life threatening? It's something that is so painfully obvious that it needs to get done, not even just to unlock the potential, but just to actually ensure that, our society as a whole isn't susceptible to the next big hack.
So I think one of the things that you're highlighting is, one, the need that if we're going to have this world of connectivity, we need to validate different sources of data, heterogeneous data sets. So the inclusion and implementation of different third-party data sets into Constellation is one of the main differentiators between Ethereum. It just can't do that.
Right. I mean, like it would just require a total code change. It's just different. I mean, it's for a different use case. And the idea here is that with Constellation, what we wanted to do is give the ability to create an end-to-end secure audit trail for any kind of, event-based data, and also make that available to any other kind of, whether it's a developer, between different companies, just available to any and every kind of application out there as this kind of knowledge graph, which is it's a term. And yeah, I mean, like actually.
So why don't you unpack the knowledge graph? I think that's interesting.
Oh, yeah.
So, one of the big things that we're doing here is creating this network of data. We've got these all of our nodes are validating and mining data and coming to consensus around that validated data. And then our network can be used as a queryable database known as a knowledge graph, which was made famous by Google, right?
I'm not sure exactly where it came from, but I think that's like a big thing that they do. That's like, there's some projects out there, like if you ask questions into the Google bar or something, like they'll pull up a recipe for a cake or something. Like the ability to take some kind of like a question, if you will, like a human like generated query and turn that into an answer. The same notion is true here, where, as opposed to just typing into the search bar, human generated query, we haven't quite gotten to that level of NLP work, maybe in the future. But basically being able to run a structured query, maybe even like a SQL query across different data feeds, something called like a join, would allow us to referentially validate some kind of state. What does that mean? Well, if in the case of, let's say I'm trying to open up my car with my cell phone, right? How do I know that someone hasn't spoofed this device or taken some kind of the same event data from a different time and sent it directly to my car, and thus they have access to it? Well, you could enforce the fact that that event had to be sent within a certain time window that could be referentially validated by the wider network. or maybe the lat long coordinates of where that event actually came from, so that some person can actually almost try to pick up these this event data getting sent to a car wherever it goes from your phone, and try to index that and find a way to open up your car. So I mean, in our own lives all the time, we cross-check information in order to understand whether or not there might be there might be something, some kind of something's broken, or like, is something true or not? You know what I mean? This gives us the ability to programmatically get actual quantifiable answers about data of some state somewhere. So it kind of creates almost like yeah, I mean, knowledge graph is the great term. I hesitate to be like it's a new internet or something, but it's basically like event streams of referentially verifiable information, such that if you wanted to create some type of algorithm, or deal with something as complex as like a self-driving car, you would then have what's something called like a topological space upon which you can decide like what's actually happening here, and get greater insight for your model, and really give that kind of tractability to all of these smart systems that we currently have, but one, don't really have kind of like an inherent validation process, or two, don't really have the ability for it to be end-to-end secure without some kind of centralized authority.
And why can't, just to kind of recap, why can't smart contracts do that?
Well, there's a couple of reasons. I mean, one is you can't really store that much information. I mean, to go back to our first project, like even storing some kind of a compressed, I mean, like if I zipped a blog post, let's say I put like a few million on there, like it probably couldn't even hold that much data. So it's like, then it's funny, it's actually what I did. But what if you just create multiple smart contracts and call multiple of them? And the whole create almost like a microservices architecture inside of there, without getting into the specifics, it just wasn't built for that. I mean, it's meant to store a little bit of information and do small updates, perhaps like a token price, or host an ICO, or maybe you could do something with like a digital asset like a CryptoKitty or Pepe. But it wasn't built for processing streams of information. I mean, like there are tools out there that do this, and
sure.
So the idea here is how could we just make something like that, right? And one other thing too to mention that is really different from this notion of what the main component of this knowledge graph. This is sort of like what the wider network is. That's called a state channel. So you can think about this as sort of like the contrary to a smart contract, with thinking in that way to how we want to handle applications. So think about it like a channel on television. You like turn on the TV channel whatever 10, and you're getting a stream of information that's showing up on your screen, right? You can think of it almost just like water flowing through pipes. And with the knowledge graph, it gives you the ability to create junctions between those pipes. And those junctions actually are asking a question, or merging information together that can answer some question that someone has. So these pipes provide an end-to-end kind of security that you get at the device level. And that is something that has actually been kind of it really is sort of a huge step in what we would call the oracleization problem, which is how do you create some kind of a trusted oracle, or some way for to take outside information and have that verified by consensus. In a smart contract, there's actually, I mean, from last time I was fooling around with Solidity, there's this library called Oracle Lies or whatever, which attempts to do this by making like REST calls or something. You can provide an endpoint, but the ability to actually verify like what's at that endpoint, it's not really possible. I mean, you need to create some measure of validation for where's that data coming from, right? And in our case, It's as simple as associating these event streams, the source of the data, with the public-private key. And as long as you have correct key management for these devices, then you have this one-to-one relationship with data created and who could be creating this data. It's the same measure of security we all have with our crypto. So yeah, I mean it's the, I wouldn't say it's trusted, but yeah, go ahead. I would say there's trust.
Oh yeah, sorry, I think we were all breaking up a little bit, but I think the real impact here in what you're saying is, how do we impact businesses? Why does this impact businesses? And a lot of what we talk about internally and with several of our partners is that the next major hack is going to come in the form of IoT, where there's very little security over sensors that are measuring energy readings for smart buildings, or your remote car starter to your cell phone transmitting signals to different wireless networks. And so what we talk to are a myriad of use cases around appending our technology on APIs or as close as we can to devices to not only prevent spoofing and tampering, especially for mission critical data. Like you can imagine government outfits or any sort of IT that governs employees in manufacturing plants, that maybe warn employees of some sort of breakage or something. But also creating that audit trail. It starts with an audit trail. And when you're talking about streams of data like Wyatt is, it's really fascinating because nobody can handle, and this is where the whole conversation of throughput, and our focus at Constellation is handling massive amounts of streaming data. Just think of like how much data is streamed on like a Netflix or YouTube, that no distributed ledger technology can handle that because of, one, their architecture, two, their consensus model. And while people are making rapid changes, they're not really focused on those use cases. So it's not like who's better, who's worse. We're just addressing a vision that we see that there's going to be a need to process streaming data and create a scalable audit trail that then can be queryable and can be used in the next generation of business applications.
I mean, I think you really hit it on the head. I mean, it's something that it's not only just, it's not that it's asked for, but not even necessarily in the way that it's like, people are concerned about finding ways to secure even just their APIs, right? Like, how do I get access to who can get certain things? And the second that you have just a centralized like certificate authority or something doing identity management, that becomes incredibly vulnerable. And I mean, like, it's kind of a huge aha moment to think that there's a new way of providing this essentially identity and authentication management without relying on some centralized server somewhere that's actually it's quite vulnerable. So it's going to allow and enable certain types of applications that a lot of people could and should be concerned with the safety and the impact of.
Yeah, I'll kind of touch on there. Something that we internally also talk about as a group is just like really creating a community that owns the data, that validates, and maybe ownership isn't the right word, and correct me if I'm wrong, but or think of a better word, but it's like we're creating a network that governs massive amounts of data versus the multinational conglomerates like Facebook and Google that have figured out how to monetize your data,
right?
And nobody else can. And we're still using these applications, and they're starting to make attempts to like, oh, we're going to pay you guys some of what we make off of our revelations about your data and how you connect to different things. And no longer is the social graph seen as cool, but it's like, wow, they're making a crap load of money and we're trying to create an infrastructure that people govern their data and massive amounts of data. And our architecture, DAG, kind of allows for that versus the synchronous nature of Ethereum, right?
Yeah, no, I mean, it just allows us to actually process all the information with the same tools that these centralized multinational conglomerates are making tons of money and hacking your elections off of. I mean, absolutely, that's exactly what's happening, and we all know it. And I think from my own personal motivation, the ability to have a public source of decentralized, verifiable truth. It is going to change the game of there's not going to be policy, there's not going to be just ethics or incentive-based policy in government. It's all going to be incredibly data-driven, and I think that the ability for people to make their own decisions and educated choices to be able to differentiate what they see in the media and what they see in sort of this invisible blinder that I think is on that we don't realize is happening when we use all of our devices and are subject to advertising and targeted, search and things like that. It just creates a common ground of there are facts, and the ability to have to discern and to verify these facts is it's kind of hard to believe that it's literally now that we have the ability to truly say well, you make a claim, can you show me some kind of accessible, publicly verified, data behind that? And obviously, if somebody mentioned that before, I mean, I think people just sort of accept the fact that it would have to come from some kind of trusted source. But this really just enables all of us to have a referential source of truth to make decisions on, almost at a large national or even species level that typically was left up to whether it's policymakers or large stakeholders in the economy. And I think that from beyond the world peace hippie aspect, it's also just going to enable really simple but really necessary things that we want, just having a accurate on-time transit system. You know what I mean? If you live in San Francisco, you ever dealt with
simple as that?
Yeah, I mean, it's as simple as that. That's a real world thing. If you can have some kind of verifiable, hey, this is where things are, and you can automate things, or at least hold people and systems accountable, and really not deal with some, difficult system. I mean, but yeah, it's really just sort of the grand scheme of what does it mean to actually have publicly available, verified information. I mean, conversations become less about opinion and more about action. And I personally, that's probably one of the most motivating aspects about all of this, is how this infrastructure is almost it's kind of like a central nervous system for, not central, but decentral nervous system for us making decisions as we, create this new infrastructure and we deal with increasingly complex social and economic and infrastructural issues.
Right on.
Yeah,
that's great, man. Yeah, I mean, there's a lot of other details I think we can go into, but I don't know, for this talk, it seems like it went in a totally different direction of features and functionality and into more vision and passion and the geopolitical layout of what we're doing. So I think that was, I don't know, you guys want to add anything over there? Anything I'm missing?
No, I probably can't really talk here because I'm on the echo.
No, it's fine.
I can hear you.
Yeah, we can hear.
Oh, okay. No, I think this has been great.
Yeah, all good, guys, all good.
Okay, good. Yeah, I think that the big thing from my perspective with talking with people is around throughput. Everybody talks a lot about with Ethereum's limitations around throughput and what they're doing to kind of scale that. And Ben, you mentioned about their use case is really being focused around logistics. Do you feel that they're kind of cornered into a segment, or do they have possibility of going beyond that?
Yeah,
Sorry, it's a little weird.
No, I think like supply chain management is a big, like we need that, right? We were talking to a group of people today where, you know, Japanese Wagyu is ripped off. It's counterfeited because the delta between like the price of American Angus is like $20 a pound to $215 a pound. That delta of Kobe at the top all the way down, it's like creates a counterfeit market. But do nations want to actually adopt that? Many private companies don't really want to for their own reason. And so I think that there's a huge use case in supply chain management around traceability that doesn't need high throughput.
I agree. I guess what I'm asking is, are they isolated to that?
No. I don't think so. I think there's a lot of closed network scenarios that operate better with latency, and that inherent latency built into you know, a synchronous architecture like Ethereum might actually work really well.
Cool.
I don't know. What are your thoughts?
maybe I can chime in here. I mean, one of the most predominant use cases for Ethereum right now, I mean, is the financial use case, right? So people have been arguing that the ICO in itself is has been the prominent use case for Ethereum so far. So we have had that initial period Wyatt was talking about in the beginning, where, you know, that new world of smart contracts has been envisioned, and people spun off ideas and the logistics ideas, the traceability, the notarization, and the secure transfer of things and assets and titles from one party to the other. But along the way, we have learned that trust is being just shifted in the system. So you still have to have the issues of an ICO, the issues of a certificate. The trust is just being shifted in a technological sense, but then the actual real use case that we're seeing with the most adoption is actually trading the token, investment funds that use Ethereum as an asset, and you know, the consensus guys setting up $100 million fund to bring new money into the ecosystem. So it has shifted more from that, at least in my opinion, from that initial vision towards a financial asset class. And but that's just as an opinion piece here. What I'd be interested in, Wyatt, and maybe you can crystallize that again or a little more, is like, so we have decentralized technology, we have scalable DAG networks versus the block processing serial type of Ethereum. But what would be, apart from political, legal pressures, or just because it is actually better, what would be a reason for a company to actually use a blockchain solution over an existing infrastructure? And I'm referring specifically to infrastructures that can process these divergent data streams that come in from different sources. So maybe you can just crystallize a little more why somebody would use that actually.
Yeah, totally. And I think the most down to earth kind of like use case here is really just around identity, access management, and authentication. So I mean, typically, like if you want to authenticate, you know, a lot of the data that's coming from, let's say, like a device, and most arrays, like let's just like talk about some bigger companies like Okta or like OneLogin or something, right? Like they have a bunch of servers somewhere that are keeping track of passwords and keys. And even if you don't want to get to the level of security that I'm sure some of the government folks and whatnot we've chatted with need, hitting that centralized service it's going to be more costly than just actually getting some kind of end-to-end like verification of the data flowing through your pipeline. Not only that, like if you wanted the same level of like at least like insurance that this gives you, then you probably want to have multiple queries to those services at every single point in your pipeline. So the real end all and be all is if you're a company and you are concerned at all with data breaches, you're concerned at all with access, and you're really concerned with securing devices or APIs and making sure that that information is properly audited, and you need an insurance policy. This is like a digital insurance policy on code. It's also, one could say the same thing about a smart contract. I mean, was the idea. Like, can you get an insurance policy on what code or what operations were executed? In our case, it's an insurance policy on, definitely like I would say transitively on the code that was executed, but it's about the actual raw data that was created flowing through your network, which then also tells specifically whether or not code was running or whether or not this is the actual device that was generating the event log. So I think that the simplest thing is, like, if you're concerned with any of these issues and you want an insurance policy to, whether it's even for some, heaven, whatever forbid kind of accident, as opposed to, maybe even just dealing with billing with your clients. There's no more arguing anymore. I mean, you have a full event-based record of every kind of API call someone's made to your service. And I know for a fact that there are a lot of people which that would save a lot of headaches, time and money dealing with their revenue streams.
Got it. So every call is basically being notarized, and as I understand right now, the situation is that a lot of these calls in the current systems, they get kind of like in a black box, and nobody really knows where that request or call actually went. So in terms of the keyless entry time, somebody opens it and nobody, like we had that with Tesla, right? Where the call actually came from, which poses a security risk.
Oh, huge. I mean, I don't know if I can actually repeat more of that information, but it is a problem. And certain players have, had to deal with issues around that.
Cool.
Yeah, so you're absolutely right. And at least we I meet with folks, I hear them. So.
Cool.
Yeah, and the folks that we're talking to at that level passed on working with many early Gen 2 blockchains because it just didn't have the infrastructure that could support their needs, right? Like one of our clients that we're in the process of onboarding processes 4 billion transactions a month. Mathias, what is that like overall? What is it, like 10 times what Bitcoin's ever done, or Ethereum? I don't know, but there's got it, like in 1 month they do that. Like, it's crazy.
Right.
Yeah, I mean, that's something we specifically went through. Also, yeah, I mean, a lot of folks tried it out, and yeah, so
cool
journey. I think we had some stuff we just wanted to chat. I think we did pretty much everything. I think one thing interesting too to talk about, which is how do you actually keep one of these networks up? You know what I mean? I mean, how do we try to, especially as it becomes more expansive, we have to deal also with like network latency and issues, and we want to make sure that people hosting this information, like can at least pay for these nodes to be hosted. How do we actually like achieve that? Because I mean, you can't pay like a penny per transaction if you're processing a terabyte a day. I mean, so we came up with an interesting approach, which is sort of like a freemium blockchain model, where, as in traditional cases, and also, I don't know if you guys remember this. I remember it was like the summer of 2017. like a Bitcoin transaction costs like tens of dollars.
Mm-hmm.
No,
Yeah.
that's almost $100. Yeah.
Fucked. Like I don't care. Like I'm not gonna hate, but like that's fucked. Like that sucks. And I mean, I won't get into it, but I remember being like disappointed and couldn't really do what I wanted to do. So it's like, well, what do we really need? I mean, to keep this thing up. So in order to process tons of the stuff, we came up with like a throughput-based model where if you're validating transactions and you're performing well, you get a larger slice of the throughput. So you can think about that as sort of like a section of like the area of like a pipe. For all the info that can come through. And, for ordinary users who might just want to send something, make a trade on an exchange or send something to a friend, in the, traditional like DAG case, DAG being our like financial state channel. We wanted to allow folks to have, access to a free transaction per time window, which is currently set to be, a few minutes. And yeah, I mean, it really wouldn't bog too much down if you're processing, a lot of stuff. So in addition to that, folks who really need to perhaps monetize their state channel data on some, a state channel processing a ton of stuff. You can notarize information from that state channel, in the larger DAG network, and perhaps, do some high throughput financial transactions as well, by hosting DAG nodes and connecting the DAG node to your state channel node. So this is sort of the plug and play aspect, the real like microservices architecture kind of aspect that we wanted to enable for folks who wanted to monetize using a distributed, ledger. And, for a lot of people that may not, for a lot of the players we talk to, it's more so just about the data validation aspect. But, you can choose. And I mean, that's the real goal here, is to create something that's so, valuable and easy to use that it just becomes like a standard, if you will, in processing and for this kind of information and for these use cases.
That was great.
Thanks,
great. Yeah, I mean, that's something that we totally forgot to cover, is transaction fees and how we're approaching that. So that was great.
Yeah, I hope you guys, and I hope whoever's viewing this and stuff finds that kind of interesting. I think it's a little bit of a game changer, and I'm hoping that maybe DAG itself might actually become something that we can exchange value like cash or something. I mean, you look at Apple Pay, like, it'd be a fun app project for the community.
Yeah,
That's a great outlook.
Yeah.
Anything else, guys?
Not for me.
We're wrapping for the day. Oh, go for it.
Yeah. I mean, that's a great outlook. What do you think, as a closing question, where do you think Ethereum's going to go from here?
I think it's once again. I mean, it's a backbone of our entire community. It's definitely got its place at the table. I don't see it going anywhere. I think that eventually what's going to happen with the whole community is that different protocols will have their niche for specific use cases. Like, you wouldn't use a MySQL database when you need some kind of like Spark streaming join array thing. I mean, I don't know what your tastes are, but some people don't like to put ketchup on pie or cake or something. I don't know, but so there's a use case for everything. I think they've definitely got a place in the market, and also they're one of the most successful projects of all time, creating an open source community. Devs, like, it's something that is almost like the way that has been able to operate is something that I think we all try to achieve in our protocols. So I just want to give some props, and I do not see Ethereum or Bitcoin or some of the bigger don't really know what constitutes an altcoin if you're big 5 or big 3 or something these days, but I definitely think that there's space for every approach to a protocol.
Nice.
I love it.
Awesome.
Well, good timing, guys. Thank you. And I'll close this off. Later.
Guys.